Welcome to Level C Math on Thursday of week 9. We're starting with homework questions, the justice fractions, 10 exercises, and number 3 says 15 hours of studying before a test lets you score 75 points. At that rate, how many points would you expect from studying 18 hours? Kind of a strange question because I'm not sure things are actually proportional in that situation, but we can pretend they are. So how would we start that one? I gave you a hint saying proportional.
You have to, geez, I forgot the word. Sorry, hold on. Is it how we were doing it on Tuesday?
We did a bunch of things Tuesday. Which one are you talking about?
Like translation and proportional, doing it that way.
Yes, when we had a percent problem with what is of and percent, we could translate it into a one-step equation, or we could do a proportion. This one is just always a proportion. So we'll start out with fraction bar equals fraction bar, and we'll want to put one situation on one side and another situation on the other side. The other part of symmetry is that not only is one situation here and one situation there, but whatever words we have on the top should match, and whatever words we have on the bottom should match. If this is miles and hours, this one will also be miles and hours. If this one is gallons per day, then this one should also be gallons per day, and so on. So now we can just start reading. 15 hours of studying before a test lets you score 75 points. Most people will just put 15 hours on the top because they see it first, and the 75 points on the bottom. If you flip it, that's fine, but then on the other side, you have to make things the same. As we wrote it, hours is on top, so hours has to stay on top in the other situation. And points is on the bottom, so points has to stay on the bottom. Again, if you flipped this one, then you have to flip that one too, so they match, and points would be on the top on both. Then we keep reading. So at that rate, how many points, so the points I don't know, would you expect from studying 18 hours? So the 18 goes with the hours. Are you okay with how we went from the paragraph to the proportion?
Yes.
Okay. Then we cross multiply. I'm always going to pick the diagonal that has the y and write the y first, just because that's what my brain likes, and I'm allowed to do that. Now, the next thing to write, there were two different lines. One of them is where we just take the 75 and the 18 and combine them. The other thing is we need to get rid of the times 15 with a divided by 15. And some days this term will be written those as separate lines to be extra clear. Other times, then we just put a divided by 15 right here and know that it's this times this divided by that. Do you have a preference?
No preference.
So I will just say we need to divide by 15. Not write the 75 times 18 as its own thing. And what do we have? 75 times 18 divided by 15 gives me 90. So it's not an about equals, let's say plain equals. $90 points. Questions on number 3?
No, I think it was just a starting point for me of what I had to do. It kind of just scrambled in my head at that moment. But now that I see it, I'm pretty sure I can understand the other ones too. But I still can work on the other one.
The clues again for these are that you have two situations and they're symmetrical. You also will notice that they give you 1, 2, 3 values, and they ask for a 4th missing value. So you can always plug things in where 3 out of the 4 you have, and 1 of them is missing. That's different than what we did last time. Let me just put that on to be good reviewing. When we had the percentage problems, then there were 3 numbers, like $12 and what and 50, and we were told 2 of them and looking for the 3rd. So the percentage problems, which you can do with a proportion way, have 3 numbers and you're looking for 1 of them, and it's all one situation. That's different than what we just did, where there's 4 numbers and we're looking for 1 of them, and there's 2 situations. Let's even go to our end of term test. And use what we just said. So what's one of the problems on the board right now that is similar to what we just did with this proportion? Something where there's 2 situations and they give you 3 numbers and you're looking for the 4th.
Maybe 28, I think.
Exactly. Should we do 28 while we're looking at it?
Sure.
Was that a yes? I heard a strange.
Yes.
Yes, okay. Let's do 28 then. Okay, so I will start us off. Fraction bar equals fraction bar. What's my first situation?
$45 miles over 7.6 gallons.
Sure. And at that point, I stop reading. I don't care what it says for the rest yet. And I'll make sure that I put miles and gallons where they match on the top and bottom of the other side. Okay, now I keep reading. By which I mean you keep reading. So tell me where to put the next 2 things.
869 miles on top
Mm-hmm.
and Y on gallon.
Yep. This one happened to be similar to what we just did with Y in the bottom right, but that's not always going to be true. But whatever it is, we know how to cross multiply. Okay, 7.6 times 8 is it 69? Am I remembering? Divided by 45 gives me about 147. Questions about that one?
I'm good on this one. Thank you.
For compare contrast, did you want to do 30 or 31 while we're looking at those?
31.
31, okay. 31 is amazingly tricky. It is a very good one to do. I expect we'll actually do multiple versions of it before people take their final. So this one has a percent, a number, and some other number we don't know. So this is one of those percentage ones where something is something percent of something. The problem is that the two numbers we're given don't match. So if I thought about the whole car value as being like a pie chart, it's kind of ugly circle. Then it loses 23% of its value during the first year. So actually, let me write 23 in a different color. So this 23% is how much value goes away. So let's color it red because it goes away. The rest of the pie is how much the car is still worth. The remaining value of the car. And that we are told is $23,000. Everyone okay with my picture so far?
Yeah.
So the problem is that we want these three numbers to all be about the same situation. And in every other problem we've done like this, they have been, because no one was mean when they gave you the problem. But now, whoever designed this problem is mean. So the 23% doesn't go with the 23,000. We would need either a dollar amount here, how many dollars of car value went away, or we would need a percentage for the big slice, what percentage is left. Which one of those can we get?
I'm blank.
In this case, being blank is the second best thing. The worst thing would be to try and take 23% of the 23,000. If we tried that, don't write this on your paper, that would be taking only the green part and finding a little bit less than a quarter of that. Does that make sense? That wedge is not part of what we want at all. So don't take 23% of the 23,000. We don't know what this dollar amount is. We don't really have the tools to find that immediately. How about the percentage for the green? If we know that one pie slice is 23%, can we know what everything else is?
Would that be us subtracting 100% from 23%?
Subtracting 23 from the 100. Yes, you're thinking it correctly. 77. So this is 77%. Everyone okay with the picture now?
Yes.
So this green 23 is now a red herring. Since we have used it, it is only a distraction. We're just using these two numbers that are talking about the same situation, the remaining price, and putting them in here. So the 77 is clearly going to go where the percent is because it's the percent. Is the 23,000 the first thing or the second thing? The first one, remember, was sort of the part, the whole, I'm sorry, the part, the change, the original, the part, the change, the new, the one after the word of is the whole, the baseline for comparison, the original.
Does it go in the first one?
It does. It's the newer thing compared to the actual purchase price of the car. The car used to be worth the whole circle. That's the old one. That's the original. So if I wanted to draw that, I could remind myself that the whole thing is the original. So I'm asking 23,000 is 77% of what bigger number? Once we get this far, I think you can finish. Let's all finish together. But very, very few students will get that out of the paragraph unless they've seen it a few times. So if you've had trouble on this, if you did a practice test before, don't feel bad. This is incredibly tricky until you get shown how it works. Ready to go on?
Yeah.
Yep.
Okay, so we could translate this. That would give us 23,000 is 77%. So I will rip lock. That's a terrible drawing of Scoots. There we go. Left to go out of percent. Of becomes multiply. What is my letter? I have something stuck onto y with times, so I will divide by that 0.77. And then whatever that is. $29,870, more or less. Once you have the answer, you can check. I can take the 29,870 and multiply it by the 77 and say, ah, yes, that's 23,000, except for rounding. Other times we could have done this with the proportion method. So we would set up the proportion, fraction bar equals fraction bar. Remember what goes in the four corners. This one is the percent. This one is always the number 100, and that gives us part over whole as a percent. This one is on the bottom, the thing after of, the original, the baseline for comparison, the old value, and then the thing that's left over that you haven't used yet is the change, the new thing. So in this case, we have 77 is our percent over 100. The thing after of what? And 23,000. Cross multiply. And we'll get the same answer of 29,870. Remember, if you are a proportion method person, there's no riplop. You have a divided by 100 in the proportion, and that's how you pay for the percent symbol. Questions on that one? Okay, we skipped a slide. We also wanted to do number 10 back in the just as fractions 10 exercises. We've done this before, but it's also a very complicated one because once we set up fraction bar equals fraction bar, then there's this strong temptation to just sort of plow forward and label everything deer, and that doesn't always work. If they catch 318 deer, don't write what I'm writing. And later there's like 168 deer and 56 of the deer are tagged and so on, then everything is deer. I'm not sure if I have this set up right or not. Maybe this number and this number should be flipped. Or maybe these numbers are backwards or something. Do you see how we're all vague and don't know what's happening?
Yeah.
So let's start all over and think carefully. We have three situations in this story. By the way, I am purposefully explaining this different than I did last time, just because I've already explained it the other way. You could go watch that video. So we have the first catch of deer, where we caught some and tagged them and released them. We have the second catch, where we catch them again and count the tags and release them. And we have the entire game preserve. So what makes 10 a tricky problem is that we want two situations. And the story has three situations. So one of them doesn't count. One of them is not what we're talking about. It's not good for comparing with the others. Okay, let's try and get started. So pick one of these three situations and tell me which numbers should go on one side.
I'm not really sure.
The hint is only one of these three situations has two distinct numbers that go with it.
The amount of deers.
Let's look at them one at a time. In the first catch, there's 318 deer, but that number happens twice. It's the number we catch and it's the number we tag. So that's not going to work well. We want two different numbers on the top and bottom for a proportion problem. For the second catch, what are our numbers?
$168 and 56.
Yeah. So we have 56 tagged from the second catch out of 168 total for the second catch. Everyone okay with that?
Yeah,
So that gives us a hint. We have tagged on top and total on the bottom. We've already looked at the first catch. That wasn't helpful. We've used the second catch. That was great. How about the entire game preserve? Can we make this side on the right look like something about the entire game preserve?
You could you add together the deer that he catches?
I don't think we need to add. Let me just finish writing it. Entire preserve. Do we know those two things? Or at least one of them? How many are tagged in the entire game preserve?
would it be 56 and 318 because he released and tagged 318 deer?
Yeah, the 56 are just part of this 318. There's only 318 that have tags. If you round up a bunch, you're not going to get all 318 again. But it's still true that there's 318 with tags running around somewhere. Does that make sense?
After reading it like 20 times, yeah.
Yeah. And then the total amount of deer, that's what we're solving for. About how many deer are in the game preserve. Yet again, we're not getting much variety tonight. Y is in the bottom right corner. Oh, well. So Y times 56 equals 168 times 318. I will multiply and then I will divide. 168 times the 318 divided by the 56 gives me about, no, actually precisely 954. And that's the hardest I can possibly make these proportion problems. To review, why was this hard? Because labeling it, our first instinct was to make all of the labels the word deer, and that wouldn't help us know if we put things in the right corners. And also because the story describes 3 different situations, when it's most helpful if there's just 2 situations. We had to figure out that the first situation just told us something about the entire game preserve, and the actual catching, although that sounds exciting, wasn't a situation we cared about. So the good news is once you know this and you are allowed to use notes on the test, it's not that hard. You're just setting up a proportion and cross multiplying. It's no longer to do than number 3 was. But the just like the car one wasn't any longer than other percent sentence ones with what is and of. It just took a little bit more setting up in the beginning. We've done 29 before with different numbers. Should we do that one also while we're looking at it?
We can.
Shrink it a little so I can copy and paste it well. How do I know that I should do this with either the translate or the proportion method? What about the question is my clue? Whoops, I am wrong. I'm giving you a, this is the wrong kind. How do I know this is not something I would just do a translate method for? That's what I should be asking. Remember, for the translate method, you're wanting to find one number when you're given 3. I'm sorry, I am making so many mistakes tonight. I'm too tired. You want to find one number when you're given 2 others. You're finding 1 out of 3. Why don't I answer my question? I am asking it so badly. I will answer it myself. So this one, we know it's a proportion because I have 2 situations. I'll put one on the left and one on the right. I have the old college size and the new expanded college size. And they give me 3 numbers and ask for a 4th, which is what proportions do. Unlike percentages where you are given 2 numbers and find a 3rd. Okay, what are my old numbers before my college gets bigger?
608 and 32.
And I'll always want to label it so I know to do the same on the other side. So students we have on top, instructors on the bottom. Again, you could flip it, but if you flipped it, you have to flip it both times. So make sure your words match. Okay, and now once you've expanded, the students is 1,919 and the instructors, we're not sure. This problem is tricky because there's a last step at the end. So pay attention for that. We won't be done just because we cross multiply. Okay, again, we have y on the bottom because we picked instructors on the bottom. So y times 608 is 32 times 1919. Okay, so 101. Okay, what else do we need to do? Who has eagle eyes about this paragraph?
Do you subtract 32 from the 101?
Yes, exactly. So it asks not how many instructors will there be, it asks how many more does it need for hiring. We don't have to rehire those 32 it had before. Everyone else see it now that it's on the board?
Yes.
So slightly tricky, but not too bad. And again, you can use your notes when you have to do this on the test.
Now, I'm just curious because I know there's two ways there's multiple ways of doing this problem.
Yeah.
Is it easier to just find the amount of instructors per number of students, because it would be 19 instructors per number of students, and then you just, once you find that ratio of instructors to students, divide that by the number of students?
You
And
can
then-
certainly do it that way.
Would that be easier than this method?
There's two problems with that method. First, the unit rate that you find is often something with a decimal, and some people don't like that.
Fair enough.
So this way, unless the problem had decimal numbers inside it to start with, then especially if I don't try and do any, the only time I do any division that might make a decimal isn't till here. So I'm really just rounding once and then I'm okay.
Okay.
So this method avoids decimals a little more. Then the other thing is that in the method you described, you have to know, once you get the unit rate, then you're squishing together the unit rate and some other number. Then do you divide or do you multiply? And if you've done a bunch of them, then you know whether you're dividing or multiplying. But otherwise you have to figure it out or follow an example problem or something. Whereas this way, if you set up the proportion, it tells you which numbers you multiply and which one you divide. So you don't have to be awake and alert compared to the other method.
Okay, thank you.
But yes, the unit rate method is fine. You just have to not mind decimals and be on your toes very slightly more. Does anyone want me to do on the board what Joel described?
You can.
So what he is saying is that he is someone, like others too, it's not just him, that wants to do this with first find a unit rate.
Yeah, because whenever, like, the first thing I look at when I see that problem is just, oh, there's a unit right there. I can use that.
So if we have 608 divided by 32, what was that?
It'd be 19.
19 students per instructor. And then once you have the unit rate, then you're going to use the unit rate. So now we're jumping up to 1,919 students. Are we going to multiply? Are we going to divide?
Divide.
And then at the end, it's still the same thing where we're not looking for that. We're looking for how many more they need. So we have to subtract away the 32 that are already on their staff. Ta-da. So yes, that works. And then what I was saying without the writing is sometimes this number has a decimal and that throws people off. And here, sometimes people divide in the wrong order, or they multiply instead of dividing and things like that. So it works great. This is just slightly more fail-safe. Okay, I'm going to pause for now. We're taking a break from homework and test problems by playing a game with a winning strategy. We've actually done it a little bit already, but we're seeing who will win at sub-divi. In this game, we're starting with a number. I'm going to give Emily 100. And you subtract away any factor of the number that is passed to you. And then after subtracting, you pass the result to the next person. And you want to be the person that gets to one. One wins. So Emily, any factor of 100.
10.
Okay, Ruthie, you have 90.
30.
Joel has 60.
Go with 30 again.
We've whittled this down a lot. We went from 100 down to 30 in just one round. Okay, Emily, you have 30.
6.
Ruthie, you have 24.
8.
Joel has 16.
4.
Emily's down to 12.
4.
Ruthie has 8.
4.
Joel has 4.
Dang, 2.
Emily has 2.
1.
And Emily wins. Yay. Okay, so it is Thursday. I won't see you till Tuesday. Not that we're done yet, but you'll have all Memorial Day weekend to torture your friends and family members and try and figure out the winning strategy for this.
Yay.
Yay. Okay. We're back with a different game. This time it's a dice game from the pages of dice games in the playgrounds. And this game is Fraction Bingo 20. We've each made up our own bingo card using the same set of numbers, but since they're bingo cards, then they are rearranged in different positions. Then we don't all get bingo at the same time. To figure out which number we cover up, I'm going to roll a 20-sided die. And what I roll is the numerator. So I roll it, and what I rolled was a 1. So our first number to cover up is 1/20. And if we don't have a 1/20, then maybe we have this as an equivalent fraction, or if not, then whatever is closest. So we might have to do some arithmetic with fractions to figure out which of our numbers is closest to 1/20. So any nominations for what number is very close to 1/20? Because that's not one of ours.
1/25.
1/25. So if I was to figure out how close that is, first of all, which is bigger, 1/20 or 1/25? Would you get more brownie if you had 1/20 of a pan of brownie or 1/25?
1/20.
1/20, right? We're not chopping it into quite as small a piece. So it looks like I could take 20, which is 4 times 5, and this is 5 times 5. I need to put a times 5 here and a times 4 there. And then I would get 5 100ths and 4 100ths. You might have been able to see this easier with quarters and things because hundreds a pretty easy number. So we're only off by 1/100. That's pretty close indeed. Anything else that might be even closer than 1/25th? I don't think so. Right? There's nothing like 2/40ths or 3/40ths or something. Once we get to 40ths, I have mine in order. We're starting at 34. So I think that is indeed it. So we can all cover 1/25th on our bingo board. Okay, I roll again and get a 14. So our new number is 14/20ths. What number is closest? Should we check 14/25ths?
Yeah.
3/4.
And maybe it's 3/4. So for here, we're going to want 100 as a common denominator again. And so if we do it to the bottom, do it to the top, and we're going to get 50, 70 hundredths minus 40, 56. So that's quite a bit away. We're 14 hundredths apart. I'm seeing we should do these in the other order. Maybe you can just see it now. 3/4, we're going to turn into like 75 out of 100 because 3/4 of a dollar, we know that. Just to sort of be complete, I can do that. So now we're only off by 5 hundredths. Anything going to get closer than 5 hundredths to our 14/20ths?
I do not believe so.
Actually, there is. There's something that is a either reduce or unreduce of 14/20ths.
7/10.
7/10, right? That one isn't off by anything. It's exactly 14/20ths. We just divided by 2 top and bottom. So on yours, cross out 7/10. We did some good math needlessly. We could have just noticed 14/20ths and 7/10 were the same. Ready for a third number? How are your Jamboards doing? Okay. We can see who is the kind of person that crosses out all of the free spaces right at the beginning.
Shots fired.
Glad he said it and not me.
I do need to figure out how to fix the battleship kind of game. The spies and sonar. Okay, I'm rolling again. 19/20ths. Can we reduce or unreduce to get to anything? If not, what is closest?
Thirty-eight fortieths.
It is 38/40. Everyone see that? We just double the top, double the bottom.
Yeah,
No, that's the wrong pen. Okay, 4/20.
One-fifth.
Everyone agree? Divide by 4, top and bottom.
yes.
Okay. Now I'm rolling 16/20.
4/5.
Everyone agree? Divided by 4, top and bottom.
Yep.
Anyone have bingo yet?
Not yet.
Yeah, okay, I will keep rolling. 18/20. We're not getting any repeats. The repeats are kind of interesting because once you've crossed out the one that's actually closest, you have to find the one that's second closest, and that can be more interesting. So this could be 9/10, but there's no 9/10.
Thirty-six forty.
Yep. Everyone see it? She's doubling the top and doubling the bottom. Any bingos yet? Okay, next roll 3/20. So if we double it, we get 6/40, but that's not on the board. What's closest? Before it kind of helped once to make something over 100. If we made this over 100, how many hundredths do we have?
1500s.
1500. So maybe it's easier to look for something close to 1500ths. We don't have a 1500ths. Do we have something very close? Maybe a 14 or a 1600ths, one more or less?
No, I don't think so. No. Not like that exact numerator and denominator.
Actually, we do. There's a 1600ths hiding somewhere.
Really now. 16 25ths.
Nope, because if you did times 4, top and bottom, the 16 is going to get a lot bigger. You're halfway
Or
there.
25.
4 25ths. Then if we do times 4, top and bottom, we get to that. So everyone on your bingo board, cross out 4 25ths. Any bingos yet?
Not
Not
yet.
yet.
Yeah, okay. I will roll again. 15 20ths I roll.
3/4.
3/4 it is. Okay, I got a bingo. Anyone else get a bingo?
No.
Should we keep going? Get a second place?
Yeah.
Yeah.
It's not satisfying if the teacher wins. Okay, 11 20ths. If we double, we'd get 22 40ths. That's not really close to our 40ths. If we divide by 4,
11 23rds.
11 23rd. I mean 25ths. That one might be closest.
Yep, I just wrote it badly.
So let's see, if we take away 11 25ths, how close are we? As before, we'll do a times 5 and a times 4 to get to 100. So we get 55 hundredths minus 44 hundredths, which is 11 hundredths, which it's a little more than a tenth, right? That might well be the closest one, but it's not amazingly close. If we go down to 9 25ths, is that going to be closer or farther away?
Farther.
Farther, this is going to be smaller. The difference would be bigger. How about 14 25ths?
Just about to say that.
If I do that times 4 top and bottom, then I'm getting what, 40 and 16 56 100ths. That's only off by 1 out of 100. Another one that might be worth checking is just 1/2. We could take 1/2, that would be 50 100ths. That would be closer than what we had with 11 25ths. It's 5 hundredths away instead of 11, but it's not as good as this one. That's only 100th away. So everyone can cross out 14 over 25. Ready to keep going?
Yeah.
Yes.
Okay, let me clean up my board. Okay, I am rolling and getting 9 20ths.
One half would be off by a factor of 5 as well, right?
Yeah, this is going, if we do times 5 top and bottom, it's 45 hundredths. So 1/2 is 50 hundredths. That's off by 5 hundredths. I guess I might as well just say equals here, right? Anything closer than 5 hundredths? It was on the board a moment ago, actually. Remember how we got to 44 hundredths?
Was it 11/25?
Does that look right?
I believe so, yeah.
Times 4, top and bottom. So yeah, only 1 out of 100. So quite close. So 11/25 we can all check off. Anyone have more bingos?
No.
No,
Our math is good, our luck is lousy.
Depends. Are we playing four corners?
Okay, 15/20. Have we done this one already?
Yes, we have.
So that's the same as 3/4. So now what's the next closest thing to 15/20? If we make it 100 over 100, that would get us 50/75 hundredths, of course. 16 times 4, might that be close? That would give us 40 plus 24, so 64. That's off by quite a lot. Oh, it's off by 11 hundredths. Thirty-four fortieths, maybe. Should we do some subtraction and see what's closest?
Yes.
So what I just said was 15/20 minus 16/25 was 75 hundredths. And then times 4 top and bottom would be 64 hundredths. So that's 11 hundredths, which isn't terribly close. But again, we've had this number already, so we're not expecting it to be as close as sometimes. 34 fortieths. Take away 15/20. Now we can use 40 as a common denominator. So we're getting 4 40ths. 4 40ths is 1/10. And 1/10 is 10 100ths. So what is bigger, 11 100, or yeah, 11 100ths or 10 100ths?
11 100.
11 is bigger. It's more of the same kind of thing. So this is a closer thing, a smaller difference. So everyone can cross out 34 40ths, I think. How about the fifths? Or any of the fifths closer? That's going to be 40 over 100, right? Times 20 top and bottom. 60. No, they're not going to be closer. So 34 50ths.
Yay, bingo.
Oh, someone else has bingo. Oh, okay. So that is fraction bingo 20. Not what everyone wants to do at night after the kids are in bed, but probably the most fun way I know of to practice fraction subtraction.